Hello! Today we are going to be talking about SQL injection. For anyone that is unaware, SQL, or Structured Query Language, is how websites store data in order to be able to provide dynamic content to users. Over the past decade, as we've evolved to the Web 2.0 model, where websites are providing large amounts of dynamic content to users, SQL injections have been one of the most prevalent as well as expensive vulnerabilities as developers have tried to figure out how they can do this safely. Now, they have got a bit better at it over the years. As you can see from this recent annual report from White Hat Security, SQL injections now only rank 7% of the vulnerabilities that they found in websites that they scanned. Because of the complex protections that are used nowadays to protect against SQL injections, the attacks that do get through can be a bit more complicated to execute. However, in order to be able to understand how to adapt techniques, we first need to understand some of the basic attack patterns. The original SQL injection attack was your basic authentication override. I will use this example to be able to show you the basics of how SQL works. We're currently playing on hackthisite.org, trying to deface a website of some white supremacist strange group there. So what we're going to need to do is to be able to log in without the username and password for an authorized user. So when we think about how this kind of attack works, we need to think about what the database is doing. What it's doing is running a query in the background, and it goes something like this. Our insecure query takes a string that says select user ID, which would be a column name from a table of users, where another column named username would equal what we would be posting over in the field for username, and another column for password would be equaling what we would be posting over password. So if we put in correct information that was expected, such as if we just gave it the characters A, we would soon find out that we would see that the strings would be terminated. It would run this query, it would not find a match for that, and we would not get logged in. However, this can be easily overridden in this sort of an example where there's absolutely no filtering mechanisms in place. How you would do this is if the password, we instead closed out the string in our own input and then entered or 1 equals 1 or something of the like, that would always be true by the database. Ended the SQL statement with a semicolon, and then put in the comment and symbols to get rid of anything else that would be on the line to not cause errors there. We should find that we would be able to log in this sort of a situation just fine. So now let's take a look at how we would be able to dump information, the data that's stored in a database. So what we're going to be using is a site that I've got set up on my local host, just a little example site of a store. We'll take a look first and see how we would be able to discover the vulnerability. So when we take a look at the source code for the page, we're able to see a bit on how this site works. Look, we can tell that it's delivering a number of things dynamically from the database, these products that we looked at on the website there. We can see that it's most likely going to be dynamically sent over from a database when there is content like that that's going to be needed to be frequently updated and changed. We see that some of the values that are changing in each one that are posted over by the database are not too pertinent. Some are just as things like what is it named, or the location of the image and such. However, we also notice a selection that is being posted over into a hidden input field, one that we're not going to be actually seeing on the screen. That's got a integer value that is incrementing through the different products here. So when we see something like an integer value that's incrementing, it's a pretty good sign that that's most likely going to be an ID, field that's commonly held in a database, in order to be able to determine the identity of each column in there with a short integer representation. So we can prove the existence of our vulnerability by going and using something like the basic SQL injection pattern that I just showed you. Instead of inputting that their selection is going to be 1, we're just going to input or 1 equals 1. This has a use of being able to show us that we do indeed have a vulnerability, because now when we click on our baseball pet at Grindr, we're able to see all the products in the page as we did say to show them all, as 1 equals 1 is true. We're also able to see how we need to arrange the characters in our SQL injection. If there was a quote around the integer in the way that they were making their SQL statement, we would have had to also get around that. So now let's take a look at how we're able to get the information out of the database with this. We've identified our vulnerability. Let's talk about how we're going to use it. What we're ultimately going to need to do is we're going to need to figure out the column names and out of the table names that we need to be able to get into in order to extract the data that we want. So we're going to have to get into the database's information schema, which is where MySQL stores that sort of information that it needs in order to make itself work. Other database engines have similar things, although different syntax in order to reach them. This will show you the general theory. So first I'm opening up a tool called Tamper Data. This is just to make it a little bit easier to post over requests. It's a free Moz browser add-on that will allow you to be able to alter your post data without having to manually cross-site script it in every time. So we're first going to use order by statements to be able to determine the number of columns in here, as before we can union on another select query, we need to make sure we know how many columns are being returned by the first query, as union and operator requires that both queries return the same number of columns. So we're going to try order by 5. And we're going to notice that did work just fine, brought up the products, so we know that there are going to be 5 or more columns in the table there. So and let's try order by 7, and we see that there are less than 7 columns there. As that brought up an error in the database there and didn't return the product. So that means that there are 6 columns in this page in this page that are being returned by the database. So let's start figuring out how to union on additional queries to the one that's running here. So we are unioning on 6 columns from the table dual that's implicitly implied in SQL here. All that means is that it will select literal numbers in this case here. So what we can see on the page that we've generated is we can see where these columns are actually bringing live visibility to the DOM, so that we're able to retrieve the information. We can see that we've got information coming back from columns 2 and 4 here, and if we looked at the source code of the page, we could see exactly how that was working, as far as being able to as far as being able to bring back those values in certain places here. as well as instead of the information that it originally intended to deliver. And we could also see that we're getting back in the image source, column 3. So sometimes it's not going to be visible directly in the DOM, but the source code that you're able to get the information from. But now we know what columns we need to select the information that we're looking for into. Okay, so now let's go ahead and what I am doing here is I'm unioning on a select statement that's going to be now pulling the column table name and putting it into the column 2 that we had saw was visible there from the information schema database, the table name of tables here. Soon see is that we're able to get some of our table names back from the database here where we saw that visibility on the page. However, you'll quickly realize, though, we're not getting down to the information that we really, looks like we are getting into some of the information in that we need as far as possible tables to get into here. Sometimes you have to group concatenate information together there, as some SQL versions will limit that here. But it looks like we've got all kinds of user-defined tables in this case that are available. So now let's go ahead and find what some of the information that we might want to get into in those tables are. So to find our column names, it's actually a pretty similar, simple process here. We simply would type column name this time. Getting a little off the screen there. User seemed like one table that we might want to check out there, but of course we would be able to use the same process to check out the contents of any other tables. And we're able to see that the user table now has the columns in it. Looks like we've got all kinds of good things, including things like user names and passwords. Now getting the data out of the tables that we've now been able to identify is simply a matter of being able to select the column names in the places we know we have visibility from the table names that we've identified here. And we see that we're quite simply able to get usernames and passwords from this fake version of a site here. Now, if we wanted to, we would also be able to format that data so it could be pulled from the site in a easier to script way here by doing something like this, where we would now be selecting using the group concat function to put the username, delineator, and the password into one of the columns here. And then what we would be doing is selecting it from a subquery of another select statement that was returning that information within a specified limit, so that we would be able to then put an alias on that, so that we would be able to get a portion of the information at a time, as MySQL will be limiting the amount of data that it is able to return with every query there, in order to prevent things like this from happening probably there. Now, one more thing to mention is that attacks on a database are not necessarily going to be restricted to just dumping information from the database, as the SQL server could be running on the site's own server there. So, for instance, let's take a look at how to get in a shell in a MySQL database to get a backdoor into a website. We'll notice currently that there is no site at this particular page under my local host here. So I'm going to show you how on a truly insecure site you are able to put in a site to do what you would like to there, be able to execute arbitrary commands remotely. So what we're going to be doing is we're going to now be putting in a union statement where what we're doing is we're unioning on a lot of blank strings that will print nothing. And then we are unioning on some PHP code that is going to do a call to the exec function that is able to run system calls as well as generate some cleaner output. One of my favorite Edge PHP functions for doing this sort of thing, although you could also use the system function if you had a little bit less room space there. And what we're going to be doing is we're going to be echoing this PHP code. As you remember, MySQL will directly write any string that you put into it, including PHP code, into an out file using the into out file command. Unfortunately, this one does actually require that you have a literal string on it here. You have to be able to get in the single quotation and mark. At any other point we might have put one in this video, you could use this equals char function, or just as OX hexadecimal symbol for it to convert into getting a single quote if it was filtered. Here it actually does need to get in. You also need to find a unprotected directory. We're using the example of an image directory, just guessing that they had some files to upload here. It doesn't look like we have much at this page, but now when we get to this page, we'll see that suddenly there is a page found. So now we just need to put in a command giving as it takes get parameters. Let's just do this on this box would be fine. And you're able to see that you're now able to execute remote commands on their server through your backdoor here. So those are some of the dangers of SQL injections and some reasons you might not want them on your website. You might want to make sure that you're correctly binding your parameters. Look up what that means through whichever server-side language that you're using to be able to find all the functions to make sure that you are not vulnerable to SQL injections on your website. But this is also the basic syntax that's used in many of these SQL injection attacks, so that you're able to then take a better look at websites and be able to do some of the things that we're going to be getting into as far as next week, as far as ways to get it around some of the filters that they might not have quite all the way protecting them like they think they do. All right, thank you very much. Thank you for coming.